Mercury, the planet closest to the Sun, continues to baffle scientists with its many mysteries. Though it's the smallest planet in our solar system, its features and behavior are anything but ordinary. For years, astronomers have studied this tiny, scorching world, uncovering phenomena that were once thought impossible. Among the more astonishing discoveries are signs suggesting the possible presence of diamonds on its surface, an idea that has only deepened the intrigue surrounding this extreme environment. Mercury's interior is just as enigmatic as its surface. Its core is disproportionately large for a planet of its size, leading scientists to question how such a structure could have formed. Why does Mercury differ so radically from the other rocky planets? Interest in Mercury intensified with the beginning of space exploration. For centuries, its surface remained a mystery, hidden from even the most powerful telescopes. That changed in 1973, when NASA launched the Mariner 10 spacecraft, the first mission to visit Mercury. During its flybys, Mariner 10 captured detailed images of Mercury's heavily cratered terrain, revealing a rugged landscape reminiscent of Earth's moon. Even more surprising was the detection of a strong magnetic field and an oversized core, findings that contradicted earlier assumptions about the planet's composition and internal dynamics. Decades later, the Messenger mission, launched in 2004, took our understanding of Mercury even further. Unlike Mariner 10, Messenger was designed to enter into orbit around the planet, allowing it to conduct a more thorough and extended investigation. Over the course of its mission, Messenger sent back more than 200,000 images, unveiling vast areas of Mercury's surface that had never been seen before. Among its most remarkable discoveries were elevated levels of calcium and magnesium on the planet's darker side, an unexpected chemical pattern that puzzled researchers and hinted at complex geological processes. Additionally, Messenger observed that Mercury's magnetic field was significantly stronger in the northern hemisphere, a phenomenon unlike what is seen on other planets. This forced scientists to rethink theories about Mercury's internal structure and the way its magnetic field is generated. Unlike Earth, where the magnetic field comes from the churning of liquid iron in the core, Mercury's magnetism appears to arise from a different, less understood mechanism linked to its unique internal makeup. Mercury's surface conditions are among the most extreme in the solar system. During the daytime, temperatures can soar to an incredible 430 degrees, 860 degrees, hot enough to melt lead. At night, the temperature plunges to a frigid 180 degrees, 292 degrees. These wild swings are due to Mercury's extremely thin atmosphere, which is unable to retain heat. Despite this hostile environment, scientists were surprised to find evidence of volcanic activity. In 2012, data from Messenger revealed signs of pyroclastic deposits, indications of explosive volcanic eruptions. This challenged the previous belief that Mercury had long been geologically inactive. Another groundbreaking revelation came in 2020 when scientists identified water ice inside some of Mercury's polar craters. These craters, located in areas that never receive sunlight, are cold enough to preserve ice, even on a planet so close to the Sun. This astonishing find sparked new questions. Could simple life forms like the extremophils found on Earth exist in these icy pockets? The discovery didn't suggest active life, but it opened the door to the idea that the ingredients for life might be more widespread in our solar system than once believed. The story of Mercury is far from over. In 2018, the joint European and Japanese mission, Bepi Colombo, launched with the goal of reaching Mercury by 2025. Its objective is to build upon the foundation laid by Messenger, providing deeper insights into the planet's chemical composition and geological history. With each mission, Mercury reveals more of its secrets, captivating researchers with its unexpected complexity. One of the most curious aspects of Mercury is how it moves through space. Unlike most planets, where a day is shorter than a year, Mercury reverses this expectation. A full orbit around the Sun, the length of a Mercury year, takes just 88 Earth days. However, a single day on Mercury, measured by one full rotation on its axis, lasts 176 Earth days. In other words, Mercury's year is shorter than its day. This odd arrangement leads to bizarre effects on the planet's surface. If you stood on Mercury, you would see the sun slowly rise, stop, reverse direction briefly, then continue its journey across the sky. This strange solar motion results from the interplay between Mercury's slow rotation and its fast orbit. Scientists attribute Mercury's slow spin to a phenomenon called tidal coupling. Over billions of years, the sun's gravity has tugged on the planet, gradually slowing its rotation. But unlike Earth's moon, which is fully tidally locked, Mercury's rotation is in a 3.2 resonance with its orbit. This means it rotates 3 times for every 2 trips it makes around the sun, a unique and stable rhythm influenced by the sun's immense gravitational pull. In 2022, another stunning discovery emerged from the data collected by the MESSENGER mission. Researchers found nitrogen trapped beneath Mercury's surface, an element that might be a remnant of a long-lost atmosphere. This revelation raised the possibility that Mercury may once have had a thicker atmosphere, which was later stripped away by intense heat and solar radiation. If so, what was Mercury like in its early days? Could it have supported conditions different from what we see today? The polar craters of Mercury continue to be a focus of scientific interest. Not only do they contain water ice, but they also appear to hold dark, carbon-rich deposits. These organic materials are believed to be more volatile than the surrounding ice, suggesting they may have been delivered by comets or asteroids. Because these craters remain permanently shaded, they create a kind of natural freezer that protects these substances from degradation. The discovery of these organic compounds in such a harsh environment challenges what we thought we knew about the survival of complex molecules in the inner solar system. Even though Mercury is not considered a candidate for life, the presence of organic compounds hints at something deeper. These molecules are the building blocks of life, and finding them on Mercury suggests that the materials necessary for life are more widespread than we had imagined. It also offers insight into the early solar system, how organic matter formed, where it traveled, and how it was preserved. The origin of these compounds remains a mystery. One leading theory is that comets, known for their rich organic content, bombarded Mercury in its early history, depositing these materials on its surface. If true, this provides a fascinating glimpse into how planets, even the most inhospitable ones, might serve as archives of solar system history, preserving clues about the processes that shaped the building blocks of life across space.